that you really have to complete that we'll be able to kind of do that together. But so there's a lot of lessons like yesterday's. I felt like a 10 out of 10 going into that lesson in terms of teaching it and helping everybody understand. I'm feeling a 7 out of 10 today, okay? So I need you to lean in and try to work with me a little bit, okay? All right, so here we go. I'm going to write a couple things on the board. I'm going to write y is equal to 2x. Y is equal to x squared. And y is equal to 2 to the x power. Okay? This is the most important part of the lesson, the front part. Okay? You're going to understand the y. Notice that each of these has an x and each of them has a 2. We all on the same page? Do you know what shape this one makes? Parabola. Do you know what shape the first one makes? If it's x to the first power, it just makes a line, yeah. That's it. So today we're trying to figure out what happens if the 2 is in the base and the x is in the exponent. Everybody agree that that's different? I'm going to go to my calculator, and I want you guys to kind of see what's happening here, but I'm going to go in, I'm going to type in 2 raised to the x power, and I want you guys to try to see if you can understand what's going on as I change these values. So I'm going to plug in 0. That means 2 to the 0. Anybody know what something to the 0 power is? It's 1. Now I'm going to take 2 to the first power. What's 2 to the first power? 2. How about 2 to the second power? 4. 2 to the third power? 8. As I type in these values, what's happening to the y value? It doubles. And if you were to describe to somebody without saying it doubles, you would say that as x gets bigger, y gets really big, right? Would you agree that y gets really big really quickly?
Yes.
Yeah. Now I'm going to change this a little bit, okay? So we see that as x goes in this direction, the y value goes up rather quickly. Now what happens as we let x go that direction? We're going to have x go to negative numbers, okay? So instead of 1, we're going to go negative 1, and I get 0.5. I go negative 2, and I get 0.25. Negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. Talk to the person next to you. How would you describe the that direction? Go, talk. Come up with something. How would you describe that?
For the most part, it is really last one. Yeah, the last one really is.
Okay, are these numbers getting bigger or smaller? Smaller. Are they becoming negative? They're always staying positive, aren't they? But they're getting very, 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 very small. And instead of doubling, it's half the value each time. It's 1/2, 1/4, 1/8, 1/16, so on and so forth. So therefore, here's what we know. This shape of 2 to the x, it starts out low and then it gets really big. We call that exponential. There are things in real life that grow exponentially. For example, the national debt is growing at an exponential rate. Anybody know what the current national debt is in the United States?
Yeah, surely.
About 35 trillion, okay? And it doesn't matter whether it's been Republicans or Democrats, people have contributed enormously to the national debt. After millions, you get billions. After billions, you get trillions. After trillions, you get quadrillions. Will you be alive when the national debt hits $1 quadrillion?
Yes.
That will be the final problem that we do in this class, is to calculate what year do we expect the debt will reach 1 quadrillion. And by the way, I started doing this problem 20 years ago, and I could predict where we were going to be 10 years later, and we were there. And I could predict where we're going to be right now, and we're right on target. Right on target. So I'll show you guys to see if you'll live to see it. So here's what we have. If you have a base that is less than 1, y equals 3 to the, or a base that's greater than 1, the shape looks like that. It goes through the coordinate 0, 1. And the reason why it goes through 0, 1 is because anything to the 0 power is 1. Some of you may be wondering why that is the case, and I'm going to quick show you once, so hopefully you see it, never have to ask it again. X to the 5th divided by x to the 5th. Would everybody agree that that is x to the 0 because you subtract the exponents? And isn't something divided by itself 1? So therefore, anything to the 0 power is 1. For all of you who don't like proofs, I just proved that. That's a proof. Kind of a nice proof, isn't it? There you go. So it goes through the coordinate 0, 1, and it looks like this. It stays real low off to the negative side, and it gets really tall quickly off to the right side. We call this part of the graph right here a horizontal asymptote. An asymptote is a line that the graph approaches. So it gets really close to this off to the left-hand side. It never goes below it. All right. This one is 4 to the x. So it's going to look just about the same. The only difference is, what do you think the plus 1 does to it? If I gave you x squared plus 1, what does the plus 1 do to that x squared? Do you remember what we did?
Moves it up.
Moves it up 1 unit. So instead of the asymptote being at 0, the asymptote is going to move up 1 unit. And instead of going through the coordinate 0, 1, it's going to go through the coordinate 0, 2, up 1 more unit. It does not drop below the asymptote. Let's look at the one below it. 10 to the x minus 1 plus 2. I'm going to do this in 3 stages for you. Okay? The parent function looks like this. What happens if we do the plus 2? It's going to move it up 2. Okay? Anybody know what the x minus 1 will do? For example, suppose I had x minus 1 quantity squared plus 2. Remember how the plus 2 moved it up to? What did the x minus 1 do? To the right 1. So we're going to take this graph, we're going to move it up 2, and we're going to move it to the right 1. So let's focus on this point right here. If it moves up 2 and it moves right 1, where's the new spot for the point? It was at 0, 1. Where's it going to be now? Up 2 will bring me to 3. Right 1 will bring me to 1. So it's at 1, 3. That's my new location. If I move it up 2, okay, that changes the asymptote. the asymptote is going to be up 2 units as well. If I move it right, does that change the asymptote? No, the asymptote's already stretched horizontally, so it doesn't change it if you move it left or right. So that's going to be the new shape where it heads off through that point. It's moved up 2 and to the right 1. Notice how this number is less than 1. If it's 1/5 or 1/2 or 1/3 or something like that, then it switches shape. Instead of starting down and finishing up, it starts up and it finishes down. So let's look at this one right here. I'm going to do it in a couple steps, all right? I have negative 1/6 to the x plus 2. So it's 1/6. So is it going to start down and finish up, or is it going to start up and finish down? Start up and finish down. So I'm going to draw the parent function just so I can see. And then I want you to talk to the person next to you. What will these two things that you see there, what will those things do to the function? How will they change it? Go, talk. What will it do? Okay, I heard a couple people say it. What does the negative on the outside do? It creates a flip. Good. And what will the plus 2 do?
Up 2.
Up 2. So I do it in that order. I do the flip, and then I add 2. So I'm going to first flip it. I'll show that in red. And if I flip it, it would look like that. So notice that when I flipped it, the point moved from 0, 1 to 0, negative 1. And now I have to take the whole thing and I have to move it up 2. I'll do that in the color black. 1, 2. So now my new asymptote is here. And this coordinate, instead of being at 0, negative 1, it moves up 2 spots to 0, 1. And we see it looks like that. So the black graph is what we want. Flip to your homework. And we are going to try 5 problems together. You're going to try it, and then we're going to put the answer up on the board, okay? That's how this is going to work. I want you to try to draw the shape. Try to find out where the point is going to be, and try to draw the asymptote as well, okay? And the first one is if y is equal to 2 to the x. Is that what we have? Go ahead, based off of the notes that we took, try to come up with the general shape of y is equal to 2 to the x. And you give you about 1 minute to think that through. Okay, here's what I want to see from you. That 2 to the x looks like this. It's going to go through 0, 1, and it has the asymptote right on the bottom. How do I know that it starts down and finishes up? What tells me that? The fact that I have a 2 there, not like a 1/2 or something like that, right? So the number is bigger than 1, so it starts down and finishes up. Okay. I now want you to look at the one right below it. Y equals 1/4 to the x. Okay, I see that this is a 1/4. This is a number that's smaller than 1, so how does that change the graph? It's going to start up and finish down. Still goes through 0, 1, but it starts up and it finishes like that. The asymptote, still just like that. Okay, about that basis? All right, I want you to move over to the right. The next one, 10 to the x minus 3. Try to see if you can sketch 10 to the x minus 3. All right, so if you subtract 3, that's going to move the asymptote down 3 units. So the asymptote should sit down at -3. This point right here of 0, 1, that should move down to 0, -2. Did somebody make a mistake that they would be willing to share?
But like 0, -3 for the point or whatever.
Do you see why? So thank you, Chuck. That's probably the most common mistake that people make. Do you see that the point is always 1 unit above the asymptote? So the asymptote moves down 3, the point still needs to be 1 unit above it. Okay? Yeah.
I just have like a question. So the 10, that doesn't do anything?
So it does a little bit. So for example, we're not showing it, but whether it's a 10 or a 4 or a 2 or a 25, as long as it's bigger than 1, it has that shape. Now the truth is that the bigger the number, the steeper the curve becomes. Okay? The steeper the curve becomes. Which is interesting because we miss kind of the time in our life where it was most applicable to talk about this. Do you know the situation we encounter in life where things were growing exponentially and we were all super scared about it? COVID. So we started with almost hardly any cases, and we were worried about when do we get to the point where it's going to take off. So one way to think about it is we were hoping to keep the base on the smaller side, And then there came that point, we knew that it would rise, it would peak, and then it would drop back. But how do they talked about flattening the curve. Now this is not a exponential function, but the idea is still the same, and that's what we were trying to really work towards. So one of the funniest things about, well, I won't say because we're recording right now. I'll say it afterwards. Don't want to get too controversial, but okay. So we're just going to try two more here. I want you to do this one. Y is equal to, and I want you to do the negative 4 to the x power. See if you could graph y equals negative 4 to the x power. $20 seconds here. Okay, so this is what the function wants to look like. That's the parent function. I'm going to go back to London and Alexia's kind of comment about this number here. I want to be clear. This is not negative 4 to the x, okay? This is 4 to the x, and then we apply the negative. That's what this means, okay? So the number is still bigger than 1, so it heads on up like that. The negative will create a vertical flip. So it should go like this. It goes through 0, negative 1, and it has this horizontal asymptote like that. Okay. Yeah, I really like the last one. So the 1/3 to the x minus 2 plus 1. Try that very last one. That'll be the last one that we do today.
No, it switches. The meaning switches the direction. So you go this way, it goes this way.
All right. The parent function wants to look like this. Okay? And so the two transformations are it's going to move up 1 and it's going to move to the right 2. So if it moves up 1, then the asymptote also moves up 1. So the asymptote should be at 1. The coordinate is going to move up 1 and it moves right 2 units. So the coordinate should be 2, 2. So we're not going to test on this, but I just want to make sure that the key points to what we talked about today are all understood. What shape does that make?
Fine.
A line. This makes parabola, and this starts low and gets big. What if it was y equals 1/2 to the x? Starts larger, gets smaller. You okay with that?